Hi everyone, it's Miss Lenorovitz, and this presentation is going to be about scientific notation and how to convert values between standard form, scientific notation, and mybp, or millions of years before present. As we go through this presentation, please feel free to pause or stop it or rewind as you need it, whether you're watching it for the first time or whether you're rewatching it to pick up on some details you may have missed when we went over this in class. And just for your convenience, these notes are roughly going to follow the format that's on the handout that we used in class, which is also linked on our weekly learning plan. So we'll first talk about converting between standard form and scientific notation. We'll go through the steps that you're going to need to take and a few examples. Then we'll go through how to convert from scientific notation back to standard form. You're then going to have an opportunity to pause and do a couple practice problems. And then we'll switch gears and we'll work on converting between standard form and millions of years before present. Again, we'll go through the formulas and steps, first to convert from standard form to mybp. We'll go over examples, and then we'll do the reverse, going from mybp to standard form. And on that content as well, you'll have a chance to pause and practice and check your work. So let's get started. All right, so first, what is scientific notation and why do scientists use it? First thing it is it's a way to write really, really big and really, really small values efficiently and accurately. And the reason scientists like to use it is not because they're lazy, but because they are efficient and they want to use shortcuts whenever is possible. And they also want to make sure that they increase their accuracy. Now, using scientific notation with really large and really small values prevents errors of translation. It also makes doing math a little bit easier. So in scientific notation, you use a power of 10 to create a shorter version of a number. So what are the rules for scientific notation? To be in proper scientific notation, the number must be written with a number that starts between 1 and 9.9999999. That number is then multiplied by a power of 10. So down below here, you're going to see a value, 23 times 10 to the 5th. This value is not in proper scientific notation. I'd like you to pause the video for just a second and see if you can identify why. Hopefully, what you've recognized is that first value here breaks our first rule. 23 is not between 1 and 9.99999, so we would need to make an adjustment. Right now, the decimal point, though not shown, is after the 3 here. We would need to move the decimal point between the 2 and the 3, and then that would actually change our exponent. So if we had written this as 2.3 times 10 to the 6th, it would be in proper scientific notation. So let's go through how you actually do scientific notation. What are the steps or the formula for doing it? There are 3 big steps. The first one is you place the decimal in your number. Oftentimes when we write a value, we may not put the decimal in place. So if you were talking about somebody who had $2,000, you might not always put in the decimal and then the 00 after that. So you want to put the decimal in so you can visibly see it. Second step is you want to move the decimal so you have a number between 1 and 9.9999999. Then the third step is you count how many spaces the decimal moved. The number of spaces the decimal moves becomes your tens exponent. If, when you're moving the decimal, you are moving it to the left, so if you're starting with a really large value, then that exponent is going to be positive. If you moved the decimal to the right in order to get it in the right position for step number 2, you started with a number that is smaller than 1. In that case, your exponent is going to be negative. So let's look at a couple of examples. Here we're looking at a grain of an amoeba, and we're going to represent its size in scientific notation. You're looking at a view of it under a scanning electron microscope here. If we measure the diameter of that amoeba under the microscope, we would find it's 0.0003 meters across, which is super tiny. Another way to think about this size is 0.3 millimeters in size, very small. So our first step, we would move the decimal between the first 2 numbers so that we're creating a number between 1 and 9.999. So that means we're moving this decimal from here over to here. The next thing we need to do is count how many spaces we moved that decimal, and that number becomes the tens exponent. So we moved it over 1, 2, 3, 4 places to the right. Notice as well that our starting value here is smaller than 1, so our exponent is going to be negative. So our value of 0.0003 meters expressed in scientific notation is 3.0 times 10 to the negative fourth meters. Notice as well I've held onto the units here. That's an important skill in science. Let's do another example, the Big Bang, the origin of the universe. To our best understanding today, based on the scientific evidence that we have, the universe is approximately 13,700,000,000 years old, or 13.7 billion years ago, the universe came into existence. So how would we take a number that is huge like that, 13,700,000,000, and put it in scientific notation? So here's our value. Notice that the decimal is not shown, but if we were to put it in, it's going to be right here to the right of the last zero. That 13,700,000,000 years ago can be expressed as 13.7 BYBP, or billions of years before present as well. We'll get into that notation in a moment. The first step is we're going to move the decimal between the first two numbers. So that would be 1.37. Again, we want a number between 1 and 9.99999. So we need to move the decimal. The next thing we're going to do is count how many spaces the decimal moved, and that number of spaces becomes our tens exponent. So our decimal started here to the right of the last zero. We moved it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. And because we started with a really big number, our exponent is going to be positive. So when we express this in scientific notation, it becomes 1.37 times 10 to the 10th, because we moved the decimal point 10 places. So what if we go in the other direction? What if you start with scientific notation and you want to go back to standard form? Here there are 4 steps. They're pretty simple. You're essentially going in reverse. The first step is that you're going to read the exponent. That's going to tell you how many places to move the decimal point. The second step is you're going to move that decimal the number of spaces. If the exponent is positive, you're going to move the decimal point to the right, making a bigger number. If the exponent was negative, you're going to move the decimal to the left, making a smaller number, a number smaller than 1. Step number 3, for any places you needed to move the decimal that do not contain a number, you're going to replace those with zeros. And then the last step, step 4, as you would in any kind of standard math situation, is you're going to put in any commas to indicate an easier way to read the number. So let's look at an example down at the bottom. Here we started with, Here we started with the number 3.29 times 10 to the 4th. Our exponent here is 4, and note that it's positive. So that means we're going to be representing a number that's bigger than 1. So we'll take our decimal point, and we're going to move it 1, 2, 3, 4 spaces to the right. Notice that 2 of those spaces do not contain numbers, so I'm going to put in zeros as placeholders here. So that number in standard form on our way to finishing is 32900. Our decimal point is now right over here to the right of the 0. So that we can make that number easier for everybody to read, we work from our right to our left, and every 3 digits we put in a comma. So 3.29 times 10 to the 4th in scientific notation becomes 32,900 in standard form. All right, let's try a couple more examples. Again, you can pause to work on these on your own. Here we have 1.23 times 10 to the 5th. When we convert from scientific notation into standard form, we're going to move the decimal point here to the right because we have a positive exponent, 5 places. So we move it over 1, 2, 3, 4, 5. We have a couple of zeros that we need to put in for placeholders, so this number becomes 123,000. Our decimal point would be here to the right of the last 0. In our next number, 6.806 times 10 to the 6th, we're going to move our decimal point 6 places to the right. We know it's going to be a number larger than 1 because our exponent is positive. That becomes 6,806,000, and the decimal point would be here. So I'm going to have you pause the video here, if you haven't already, and practice with these practice problems. All right, hopefully you're checking your work now. So our first value, 1.23 times 10 to the 5th, in standard form is 123,000. Our second value, 4,000 in standard form, becomes 4 times 10 to the 3rd in scientific notation. Our third value, 2.48 times 10 to the 3rd, becomes 2,480 in standard form. Our fourth value, 6.123 times 10 to the 6th, becomes 6,123,000 in standard form. And our last value that's here, 306 million, becomes 3.06 times 10 to the 8th. All right, hopefully you're on the right track with those. We're going to use another form of conversion now. We're going to use a form of conversion that we oftentimes use when we're speaking about geologic time. Earth has been around for a very long time, approximately 4.6 billion years. And so we oftentimes want to talk about expanses of time in millions or billions of years. And for that, scientists have an abbreviation mybp, which stands for millions of years before present. So how do we use this? This as well allows us to have a little bit of a shortcut. So if we were talking about 1 million years and we wanted to express it in mybp, we simply divide by a million. So a million years is 1 mybp. 237 million years becomes 237 mybp. And 4,600 million years becomes 4,600 mybp. You probably already have figured out what we're doing to get from standard form into mybp, but let's go over some simple rules. 2 steps. The first step, if you're starting in standard form and you want to get to mybp, is to divide your original value by a million. So if we had 27 million, we'd take that original value and would divide by a million. The second step, and very important one, is we would need to then add the abbreviation mybp to our final answer. So 27 million years becomes 27 mybp. Note that if we didn't have this mybp here, 27 million years does not equal 27. So that abbreviation is really important. When it gets tricky, it can get a little tricky if you have a value that is not exactly equal to divisible by a million. Let's say we have 27,030,000 years. We still do the same steps. We divide by a million. We would move the decimal point. When you're dividing by a million is 10 to the 6th. You're literally moving the decimal point 6 places to the left. So we would simply do that. We get 27.030000 in this case. These zeros to the right of the last number in this case are placeholders, so we can take those away, and our final answer becomes 27.03 mybp. Can it get trickier? Sure. What if you're dealing with a value that is less than a million? So let's say we're starting with 43,000 years. Steps are still the same. We're going to divide by a million. Again, that's the same as dividing by 10 to the 6th or moving the decimal place over 6 places to the left. So that would make this 0.043. We'll have some extra zeros at the end. We can lop those off, and our final answer for 43,000 years would be 0.043 million years before present. All right, what if you want to go the other way around? You start off with a value that's in millions of years before present, and you want to go back to standard form. Easy. You do the reverse. You're just going to take your mybp value, and you're going to multiply by a million. So if we started with 439.5 mybp, we'd multiply that number by a million, and our answer in standard form would be 439,500,000 years. So to recap, again, to go from mybp to standard, you're going to multiply by a million. In other words, you're moving the decimal 6 places to the right. If you want to go from standard form back to mybp, also simple. You're just going to divide by a million, which means you're moving the decimal place 6 places to the left. Hopefully that helps you with each of those conversions. Remember that you can find this set of notes on our weekly learning plan, so you can always return to them as you need it. Have a great day, and feel free to reach out if you have questions.